Hi, this is Mrs. Barbera. This is AP Physics Chapter 1, Video 3. The objectives for today is to know the uncertainties in all measurements is indicated by significant figures, and to be able to estimate using orders of magnitude. Uncertainty and significant figures. All measurements have uncertainties. The uncertainties in a measurement depends on the limitations of the measuring device. For example, a meter stick versus a micrometer caliper. So the two instruments will give you different amount of uncertainties of your measurement. The uncertainty in a measurement is indicated by the number of significant figures. The significant figures are the digits that are known with certainty plus the one estimated digit. For example, suppose you're going to measure the length of the strip using a ruler. Take a look at this diagram. So for certainty, this would be 5.3 something, right? So 5.3 is for certain. Then the other one you estimate. So in this measurement, the length is 5.3. These two are for certain, plus the one digit you'll have to estimate. So the total length is 5.32 centimeters. There are three significant figures in this number. So the uncertainty is about 0.02 centimeters. So this is indicate the uncertainty of this measurement. Using significant figures in calculations, there are two basic rules. When multiply or divide numbers, the result has no more significant digits than the least precise of the original numbers. For example, 0.745 times 2.2 divided by 3.885. There are three numbers. 2.2 has the least amount of significant figures, so your answer should have only two significant figures, 0.42. Another example, 1.32578 times 10 to the 7 times 4.11 times 10 to the negative 3. Out of these two numbers, 4.11 times 10 to negative 3 has the least amount of significant figures, so you should have only three sig figs in your answer. 5.45 times 10 to the 4. Now, when add or subtracting numbers, the result is determined by the number with the largest uncertainty. What does that mean? That means the fewest digits to the right of the decimal point. So to the right of decimal point. Now you have three numbers, add or subtract. This number, 138.2, is the one with largest uncertainty because it has only one digit to the right of the decimal point. That means your answer should have only one digit after the decimal, 153.6. So the test, or all the tests we have, and exercise in the textbook assume there are three significant figures. So make sure you have that in mind. Using scientific notation to express significant figures. The uncertainty can be shown in scientific notation simply by the number of digits displayed in part A in a scientific notation expression. This is scientific notation expression A times 10 to the n. Remember, this A has to be a number greater than 1 and less than 10. For example, in this number 1000, there is just one significant figure, right? How do we express two significant figures in this number 1000? We can use scientific notation. 1.0 times 10 to the 3. This number is 1000, but it has two sig figs. How do I express 1000 with three sig figs? 1.00 times 10 to the 3. How about 4? It's 1000. 1.000 times 10 to the 3, or simply 1000 with a decimal at the end. Let's take a look at example. The rest energy E of an object with rest mass m is given by Einstein's equation E equals mc squared, where c is the speed of light in vacuum, C equals to 2.99792458 times 10 to the 8th meters per second. Find E for an object with this mass. M equals 9.11 times 10 to the negative 31 kilograms. This is actually the mass of an electron. So what is the energy for this? Now, when we can multiply this, right? Just plug into equations. So this is really a test of your significant figures if you know the rules. Out of these two numbers, 9.11 has the least amount of significant figures, has only 3. So your answer should have only 3 sig figs, 8.19 times 10 to the negative 14 joules. Test your understanding. So the density of a material is equal to its mass divided by its volume. What is the density in kilograms per meter cubed of a rock of a mass 1.8 kilograms and a volume of 6.0 times 10 to the negative 4 meter cubed? Now density is mass divided by volume. So these two divide. So we know it's 3 times 10 to the 3, but how many significant figures should you have? 3, here 1.80, 6.0 has 2. So your answer should have 2 significant figures. The answer is 2. Next topic is estimate and orders of magnitude. So estimations is needed at times, right? Sometimes we want to estimate because the calculation is rough, or we just want to see the ballpark. And it is done. How do we estimate? We usually estimate by rounding any data using in the calculations. Sometimes we round by a factor of 10. Is it close to 100 or is it close to 10? So the guess is called order of magnitude of estimates. So comparison of estimate to an actual calculation can head off errors in final results. So sometimes you can see if your result is correct or incorrect just by an estimate. So before you calculate, you should have a rough idea what is the number should be of inward range. Let's take a look at this example. You are writing an adventure novel in which the hero escapes across the border with $1 billion worth of gold in his suitcase. Is this possible? Would that amount of gold fit in a suitcase? Would it be too heavy to carry? So given 1 grams of gold is about $10 and density of gold is 1 grams per centimeter cubed. So let's estimate the size of the suitcase. That's how I did. So the size of regular suitcase, since this is in centimeters, so I just do about centimeters. It's about 20 centimeter times 50 centimeter times 100 centimeter. So it's about 1 times 10 to the 5th centimeter cubed. And we know 1 centimeter cubed is 1 gram. So that will contain about 1 times 10 to the 5th grams. And each gram is $10. So that would be about 1 times 10 to the $6. 10 to the 6 is a million. So that would only hold $1 million. So 1 billion is actually too much to be held in the suitcase. And it also is going to be too heavy. So this is $1 million is about 1 times 10 to the 5th grams. That's about 10 kilograms. That's 20 pounds. So if you have $1 billion, which is 1,000 times bigger than a million, so you will have like 2,000 pounds. It's impossible for you to carry. So the answer is no. Another example. What is the approximate number of teeth in all the mouths of everyone at VC? So let's see. For an average person, right? Average person have about 28 to 32 teeth. It depends on the wisdom teeth get put out or not. So say average is about 30. 30 teeth per person. How many people do we have at Valley Central? So we have about roughly 350 per grade, so you have 1,400 students, roughly, say 1,500 students, plus all the staff. So roughly about 2,000. So each one have 30, 2,000 times 30 give you about 60,000. So roughly, okay? That's it for today. Thanks for watching.